This question is about the apparent brightness of a star, in which we will try to calculate the luminosity of a star. But let me first tell you what is the apparent brightness concept. Okay, so you see a star and the distance of the star, we are assuming that the distance between the star and the earth is d. Okay, now each and every star in the universe can be considered luminous. Why? Because these stars are radiating a huge amount of light. Okay, and in fact all the electromagnetic spectrum. Okay, so how much light or how much energy these stars are propagating in the space per unit time, this is called power, radiated power, or luminosity. So this is the definition of luminosity. So this is called luminosity, that this is the electromagnetic wave energy radiated per unit time. Now, for example, the luminosity of the sun is 3.846 times 10 power 26 watts. So from the unit, you can also see that its unit is watt. That is a unit of power. Okay, so that's the luminosity. But when this light reaches the certain distance, after covering, let's say, 150 million kilometer away from the sun, when it covers this much distance and it finally reaches the earth, its energy, its intensity of the light decreases noticeably. So this is the imaginary sphere, and this sphere is touching the surface of earth, and its area is 4 pi d square. So that's why the apparent brightness, the light that is finally reaching the earth, its brightness at the earth is B is equals to L over 4 pi d square. So that is a formula that we are going to use in this question. So they are asking that if the apparent brightness of another star is 2b and we increase the distance 3d, okay, so what will be the luminosity of the sun, of the planet or star? So okay, students, let's try to calculate. So what is the apparent brightness at this distance, that is B is equals to L over 4 pi d square. Okay, now, so students, to find out the luminosity at a distance 3d, let's, do we know the brightness? That yes, we know, that is 2b is equals to L prime. That's a new the luminosity that we want to find out, 4 pi, and the distance is 3d whole square. Now we will simply solve it. You can equate the two equations, or you can substitute the value of b here in order to solve for the luminosity. So that will be 9 into 4 pi d square. Okay, now let's plug the value of the value of b here, and then it can be written as 2 into L over 4 pi d square is equals to L prime over 9 into 4 pi d square. So this is certainly cancelled out, and finally L prime, the luminosity of the star, is 2 multiplied by 9L, that is 18 times this. So that's why the D must be the right answer.